Oh, here I'm just saying, sometimes it's nice, you can use the same variable, but it's nice to use different variables for people realize that, well, it's going to be a different guy, right? And then restricted domain, we did this already, right? Should we need to, oh, here, maybe I didn't give you this. Let's do it again in case you didn't, right? For all boys, right? What's the negation? Is this the negation? Right? No, we're still talking about boys, right? There exists a boy, right? Remember that? So here we're saying there exists the y that's bigger than x. So we're talking about y's that are bigger than x, right? Here, this is kind of every point here is an xy point, right? And we're talking about, we're saying that this is true for everybody in here, right? For every x, there exists a y. All right, so here's some if you're doing formal logic, right? You're not allowed to say for every boy, right? For all is over the entire universe. All right. So this says there exists an object in S for which it's true. For all objects in S, it's not true, right? They're negations of each other, right? And so, right, you're not allowed to do this in formal, right? So we're going to get rid of it. And so what is this saying, right? There exists an X and S for which it's true, right? You can say, what does that mean? It means do we want to say there's an X for which X is an S and it's true, right? There exists an X that's in S and alpha is true, right? Does that make sense? Right? Here can people kind of follow that? We're saying there exists some of all the objects in the universe, right? He's an S and alpha is true for him, right? That's what we're saying exists. All right, so what about this one? This one's saying everybody in S has alpha false, right? So it kind of says if you're in S, then you're false, right? Everybody in S has alpha false. So you can kind of write that for every object. If it's an S, then it's false, right? So the guys that aren't in S, do we know anything about them? No, we only know about the X that are in S, right? If you're in S, we know alpha is false. If you're not in S, we don't know anything, right? So how do you write that down? Write it down for every object X. If you're in S, then alpha is false, right? Everybody get that? So you can always get rid of the going over for all boys, for all humans, right? You can translate it into this. People getting this? All right, now, for alls, right? We don't want to do this in general, convert for alls to and/ors and nots, right? But let's just do it here for fun, right? What does this say? When's this false? This is false when this is true and this is false, right? So it's not the case that X is an S and alpha is true, right? It's not the case. Everybody get that? And then we see that those two are negations of each other, right? Does that make sense? Right? Because this one says there exists a guy in S that has property here. This one's saying for all S, guys in S, doesn't have the property. So these are negations, and so we need those to be negations, right? All right, any thoughts about anything? Everybody good? Everybody ready for reading week? Any good plans? All right, so I've used this example a few times over the years, and I think it's a good one. We want to talk about, say, does every real have an inverse? Like 2 has a half, right? Does every real have an inverse? No, right? So this says for every x, there exists the y, so x times y is 1, right? Everybody see that? Every x has an inverse, which is 1 over x, right? Except for 0. So I remember last class we were talking about for all dogs, right? And taking the negation and dealing with that and converting it. So here's a really natural thing to want to write, right? So for all x that aren't 0, you have an inverse. But of course, we said you can't do that in formal math, right? So remember what we did here. We said for every x in some set, what do we want to, if it's in the set, right, then we know the alpha property is true. If it's not in the set, we don't know anything about it. Everybody kind of follow that, right? So that's why it's sort of what it says. If it's in the set, we have the property, right? So what do we do here? We say for all x, if it doesn't equal 0, then there exists an inverse, right? And this is just converting the implies into ands and ors, right? When A implies B is not true, right? A implies B is not true when the first one's true and the second one's not true, right? We can bring the negation in. And now it's getting to be something that looks kind of weird, but says for every x, either one of 2 things is true for every x, right? Either x is 0 or it has an inverse, right? That also makes sense, right? Because it has an inverse, covers all the cases where it's not 0. All right, everybody see that? These are just ways of writing the same thing. And then you might not like the exists over here, right? So you can put well, here, if I stuck another exists here, does this change this sentence? There exists the y for which x equals 0. I don't know, it just says that x is 0, right? We don't need y, it doesn't do any really harm. So we can bring it out. All right, everybody see that? For every x, there's a y that's the x times y is 1 or x equals 0. Now, what we might also want to do is we might want to, there is, except for some special value 0, but we could hide that and change it into x is a. Right now, where do we get the value a from? We want to quantify. Is this true for all a? Does there exist an a? Do we put if you put the a and exist a here, then it will depend on the previous things. Do we want it to depend on x and y? Right? No, we want 0 is just one object, right? We want to say there exists an a. Right? So everybody see here our statement? Say there exists an a. What is a? A0. That you give me any x, then
either it has an inverse or it's 0. And if it has an inverse, right, then there's this y that you multiply, you get 1, right? Now, this seems like a crazy sentence, and you might have seen it before because I think I've had it on tests, so it might be on some of your practice things, right? So if you want to play the game, right, it's just a game. How do you do it? You read it left to right. The prover says what? The prover has to prove that there exists to get an A. So the prover has to give a value for A. And as we know, it's their special value 0, right? And then we get an arbitrary X, right? And now I have to come up with a Y, right? What should Y be? 1 over X. We want Y to be 1 over X. But what happens if X is 0? What if, right? We know it. We're told X. What happens if the adversary gives us 0? Then what should we make Y be? I'm going to say it doesn't matter. We're not going to use it, right? So I think I often set it to be 5, right? Right? Why? Why not? Right? I can set it to be anything I want, except it has to be a real number, so it can't be 1 divided by 0. Everybody see this? And then we check. We have to prove that this is always true, right? Well, we do it by cases. If X is 0, then A is 0 and X equals A, right? And we never use the fact that Y was 0, right? And otherwise, we got what we want. Everybody good? Just a silly little example. I don't know why I